Have you ever seen a shape that has no inside, no outside, and somehow loops through itself? Meet the Klein bottle. At first glance, it looks like a weird glass sculpture, maybe even broken. But trust me, it's one of math's strangest creations. To understand it, let's start small, with something you've probably seen before. The Möbius strip, that magical one-sided loop of paper. Take a strip of paper, twist it once, tape the ends together, and boom, you have made a surface with only one side. If you draw a line along it, you'll eventually come back to where you started, without ever crossing an edge. Now imagine taking that idea one step further. What happens if you try to make a closed version of a Möbius strip? Mathematician Felix Klein wondered exactly that back in 1882 tests, and his thought experiment became the legendary Klein bottle. So, let's build it together. Take a Möbius strip, and instead of leaving it open, connect its edges in a clever way. The problem? In our three-dimensional world, connecting those edges means the surface must pass through itself. It has to intersect. But in four-dimensional space, that intersection disappears. The surface connects smoothly, creating a true, seamless, one-sided object. That's why every real Klein bottle you can buy actually cheats. It passes through itself because we're stuck in 3D space. Watch closely as I rotate this glass Klein bottle. See how the neck dives into the side and merges inside the belly? Let's pour in some colored water so you can trace the path. The liquid flows continuously, and there's no boundary between inside and outside.
Your brain might hurt right now, and that's normal. Our intuition was never designed for four-dimensional geometry.
Mathematically, the Klein bottle is non-orientable, meaning it has no consistent left or right side anywhere on its surface. Think of it as a Möbius strip whose edges have been glued together in just the right, but impossible, way. So why does this matter? Beyond being mind-blowing, Klein bottles appear in topology, theoretical physics, and even computer graphics. Topology uses objects like the Klein bottle to study continuity, connectedness, and what really defines a surface.
In theoretical physics, simuliterature puzzle.
In computer graphics and VR, non-orientable surfaces help simulate infinite loops and texture mapping without visible seams. Artists and designers also love it. It's a symbol of impossibility and beauty, woven into mathematical perfection. Even philosophers see it as a metaphor, a universe without boundaries, where inside and outside lose their meaning.
Pretty wild, right? A shape that breaks your intuition, yet fits perfectly within mathematical logic.
So next time you see a Klein bottle, remember, it's a four-dimensional idea crammed into our three-dimensional world.
Thanks for exploring this impossible shape with me. If your mind is still intact, drop a comment and let us tackle the next weird geometry.